Hello, it is March 26th, 2020. This is our first online geometry lesson. The classes were at different spots, so we're going to kind of start here. This is practice with everything you've been doing recently. We are going to be able to complete coordinate geometry proofs using the definitions and the distance formula. So, what you need to know for this is this page right here. So, um, you need to know all of this. So take a screenshot, do whatever you need to do, but we're going to be referring back to this over and over and over and over and over again throughout this topic. This is a very, 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 very important topic. This will either be a 6-point question or a 4-point question on the regions, so it's very important. So you're going to need to have all this memorized, but for the time being, refer to this right here. So again, take a screenshot, write it down, print it, whatever you need to do. There are 3 components to coordinate geometry proofs. Let's start by graphing the shape. P is 2, 6. A is 6, 8. U is 10, 6. And L is 6, 4. Let's try and keep this as neat as we can. Don't want to do that. So we always start with what they want us to prove. We want to prove that pole is a rhombus, but not a square. So I'm going to start by saying in component 1, I'm going to make this a lot smaller too. Pole is a rhombus because, and the answer to that is right here. Pole is a rhombus because all sides are congruent. It is not a square because, well, to prove it's a square, in addition to, let's get rid of all this. To prove it's a square, in addition to all sides congruent, we also have to prove that diagonals are congruent. So if it's not a square, then we're going to say because the diagonals are not congruent. The reason I'm writing small, just because this question takes up a lot of space. All right, that's step 1. Now step 2 is to calculate all the distances. If I want to show that all the sides are congruent, then I have to show the distances for all the sides. So I'm going to do the distance of PA. I'm going to do the distance of AU. I'm going to do the distance of UL. And I'm going to do the distance of LP. Now, my distance formula, which you really, 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 really need to know, is delta x radical delta x squared plus delta y squared. So I count 1, 2, 3, 4, 1, 2, 4 squared plus 2 squared, That's 16 plus 4. That's radical 20. AU, 1, 2, 3, 4, 1, 2. 4 squared plus 2 squared. Radical 16 plus 4. Rad 20. UL, 1, 2, 3, 4, 1, 2. 4 squared plus 2 squared equals radical 16 plus 4 equals rad 20. And LP, 1, 2, 3, 4, 1, 2. 4 squared plus 2 squared equals radical 16 plus 4, which is radical 20. Obviously, if you're not comfortable with distance, you need to get comfortable with distance. So ask me or ask somebody, but you need to obviously be able to calculate distance in order to do this. Now, because it's also telling me that I'm going to have to show the diagonals are not congruent, I'm going to now have to calculate the diagonals as well. So the diagonals are PU and AL. Now, since these are straight lines, I don't have to use distance formula. PU is 1, 2, 3, 4, 5, 6, 7, 8. And AL is 1, 2, 3, 4. So if it's a straight line, you don't have to use distance formula. All right, that's 3. That's 2. Now the third component kind of ties everything together. So if I said in step 1 that it's a rhombus because all sides are congruent, tell me that all the sides are congruent. Tell me that PA is congruent to AU, is congruent to UL, is congruent to LP because, well, they're congruent because they have the same distance. Now, I said it's not a square because the diagonals are not congruent, so tell me the diagonals are not congruent. Tell me that PU is not congruent to AL because they don't have the same distance. This is a 6-point question in the Regents. It's a gift of a question. However, you need to know your how do you proofs. You need to know how to do distance, and you need to know how to put it all together. But it's really not a difficult question. Hopefully at this point you can see why I did this nice and small, because these questions take a lot of space and, doing the best we can here. All right, let's go on to the next example. It wants me to prove that triangle USA is an isosceles triangle. So I'm going to start by saying USA is an isosceles triangle because, and I'm going to go back to here, and I'm going to clean this up a little bit. Get a little messy. It's an isosceles triangle because it has 2 congruent sides. Now we're going to hold off on the right triangle part for now. Let's make this a little smaller. And now let's graph it and let's go on to step 2. So we've got U for -7. We've got S, -3, -4. We've got A, 7, 0. Let's get this as neat as we can. And let's show they have 2 congruent distances. So step 2 is going to always be your distances. Ideally, you can see which 2 are going to be congruent. I mean, looking at this thing, it looks like that one and that one. So I'm going to find the distance of SU. I'm going to find the distance of UA. I want you to do it. You find the distances right now on your own. I'm going to give you about 30 seconds or a minute to do that. Again, your formula, delta x squared plus delta y squared. Again, right now you're calculating those distances on your own. When you do them out, you should have gotten rad 58 and rad 58. Now, in this step, because it wants me to determine if USA is a right triangle, for a right triangle, I need all 3 sides. So let's just find the distance of SA at this point. We'll talk more about that in a little bit. All right, step 3. So in step 1, I said it's an isosceles triangle because it has 2 congruent sides. So tell me that it has 2 congruent sides. SU is congruent to UA because they have the same distance. Now it says to determine if USA is a right triangle. To prove a right triangle, I need to show that the sides fit into Pythagorean theorem. So a squared plus b squared equals c squared. A and b are the legs, always the smaller sides. So it's going to be rad 58 squared plus rad 58 squared equals c is the longer side, rad 116 squared. The squares and the radicals cancel. I'm left with 58 plus 58 equals 116. 116 equals 116. Since that works out, it is a right triangle. So I'm gonna write. Looks like it's close stuff. I'm gonna write somewhere. USA is a right triangle because its sides fit into Pythagorean. So that's it. These questions are a little bit on the long side, but as long as you know your how do you proves, as long as you know this sheet right here, it's really not bad. Use my key to help you practice. Again, my keys, Schlansky.com. The password is Tyler. I'm going to make sure that all that stuff is there. We're going to spend 2 days on this lesson. So let's say for classwork / homework tonight, do half of it, and we're going to quiz on it tomorrow. So if there are 12, let's say your homework is, let's say classwork / homework is 1 through 6. And I'm going to tell you right now, tomorrow it's going to be 7 through 12, and you're going to have a quiz tomorrow on this. It needs to be practiced. It's very, very, very important. So I hope you do it. If you have any questions, reach out to me on Remind or Google Classroom or whatever.